So the matter of statistical notation is not the single most exciting thing that we will talk about in our time together, but it is incredibly important because remember, statistics is a scientific language. It's a standardized scientific language, and you're going to have to be able to understand that language to do it effectively, and that requires statistical notation. Some specific statistical notation that you need to be aware of right now is that scores are referred to as x. So the first variable we measure, those raw scores are called the x values. If we measure two variables, the second measurement is called y. So when we measure wake up time, we call those x scores, and when we measure also on those students' academic performance, we call those y scores. The big capital letter N is used to represent the number of scores in a population, and the lowercase n is used to represent the number of scores in a sample. This is a good time for us to talk about a notation sheet. You need to be making and keeping a notation sheet with all of this stuff at your ready disposal all the time, because there's going to be loads of statistical notation, and the more of it you get copied down ahead of time, the more efficient you're going to be at working through your problem sets. Many statistical procedures require adding up all of the scores, and that is annotated with the summation notation. The summation notation is the sigma, the capital Greek letter sigma, that kind of looks like a funny E. And it's extremely important and should get added to your notation sheet. Now, when we do the summation procedure, you need to be aware of the order of operations. So the order of operations is something that you should definitely write down right now because you're going to want it to know it later. The good news is any math class you've ever had that used the order of operations, it's exactly the same there as it is here. So the order of operations is as follows. First, do any calculation in parentheses. Second, squaring or any other exponents. Third, multiplying and or dividing, and if there is more than one multiply and divide, they should be done from left to right. Same order as how we read. Fourth, summation notation. Fifth, and finally, addition and subtraction, and if there's a series, work left to right again. Super duper important stuff. Please make sure that you have it written down and that you understand it. Many statistical procedures require to add up or sum a set of scores. And the way we annotate that is with a capital letter sigma or the summation sign. It looks like that funny E that you see in the middle of the second bullet. This is definitely something that you should add to your notation sheet right now. So now we're moving over to our virtual whiteboard to work out the first of what will be quite a few examples in our time together. But before we start using our summation notation, we have to talk about the order of operations. If you've taken any math classes at all before, you've encountered this idea. This is simply the order in which we do parts of an equation. And first, we always do things in parentheses. Second are exponents, including squaring, so any exponents get done second. Third, we do multiplication and or division, and if there's a series of multiplication or division, we work left to right, same direction as we read. After all that business is done, fourth, we can do summations using our sigma notation that we just discussed. And finally, we do any additions and or subtractions, and should we have a series of additions and subtractions, we again work left to right. So here we have four x values, 10, 6, 7, and 4, which are values on some variable that we have measured, and you'll notice that we have a sample size of 4, or n equals 4. So to do the summation of that data set, we simply add up those four scores, equaling 27. So the sum of x for this data set equals 27. Easy as that. This little type of graph that I'm drawing is a computational table, and we can do lots of useful things with computational tables. So here we have a new data set with 4 x-scores, again n equals 4, 3, 1, 7, and 4, and we can find certain values associated with those data sets. So for example, the sum of x, or the sum of x squared, or the sum of x's squared. To get started with this, we would add a second column to our computational table, or the x squared values. So you'll notice 3 squared is 9, 1 squared is 1, 7 squared is 49, and 4 squared is 16. We can use those values to solve each of these problems below. So using our order of operations, we can get the sum of x, which is 15, simply add up the scores in the x column. And we can also get the sum of x squared. Using our order of operations, we know that that's telling us to do the exponents first, so we have to square each of the values and then add them up. So 9 plus 1 plus 49 plus 36 equals 75, or I'm sorry, plus 16 equals 75. That is the sum of x squared. The third item that we want to find is the sum of x's squared. Remember, order of operations, we have to do the parentheses first, so that means add up all of the x's. We already know the sum of x equals 15, so when we square that, we get 225. We have another data set where n equals 4, so the 4x values are 3, 1, 7, and 4. To find the values that we're being asked to find, sum of x minus 1, and sum of x minus 1 squared, we need to add 2 additional columns to our computational table. So we can add the x minus 1s to get those. So each x score minus 1, so 3 minus 1 is 2, 1 minus 1 is 0, 7 minus 1 is 6, and 4 minus 1 is 3. And we can also get the x minus 1s. Because the order of operations, we take each one of those x values and x minus 1 values and square it. So 2 squared is 4, 0 squared is 0, 6 squared is 36, and 3 squared is 9. So with these values in the order of operations, we can find each of the 3 sums we were asked to find on the right side of the screen. Remember, if you have problems with any of these computations or anything else that we've talked about, you need to go to the discussion board for this week and post those questions so that we can talk about it a little bit more. Same goes for any problems you may find as you're working through your problem sets or your quizzes. Anything you're unsure of, be sure to get it in the discussion board so we can talk about it. So another example using the order of operations, we take our 3x scores and we find the sum of x, and we use that value to find the sum of x minus 1. We know that the sum of x is 15, so we do the substitution. 15 minus 1 equals 14. Here's a little bit more complicated example where we have data from 4 different subjects. We're calling them A, B, C, and D. And we have collected values from them on 2 variables, x and y. So we have their score on some variable we're calling x and each person's score on some variable we're calling y. And we're being asked to find sum of x, sum of y, and the sum of xy. So given the order of operations, we know that we're going to have to add that last column in our computational table, the xy column, that we get by multiplying each of the x scores by the y score. So 3 times 5 is 15, 1 times 3 is 3, 7 times 4 is 28, and 4 times 2 is 8. Now, given that information, we can find the values asked for. So sum of x equals 15, simply add up the x scores. Sum of y equals 14, simply add up the y scores. And sum of xy equals 54, simply add up the new column that we created by multiplying the x scores times the y scores. One last set of examples to make sure you can put this all together. We have 4 x scores, 6, 2, 4, and 2. And when you work through these in the book, that's very likely you're all to be given other than the sums that you have to find. In this case, sum of x squared, the sum of x's squared, the sum of the x minus 2's and the sum of the x minus 2's squared. So because of the order of operations, I knew that I had to add 3 columns to my computational tables. First, the x's squared, so each x squared gives the values of 36, 4, 16, and 4. Then the x minus 2 column, where I simply subtract 2 from each of the values in the x column. So 6 minus 2 is 4, 2 minus 2 is 0, 4 minus 2 is 2, and 2 minus 2 is 0. Now, the last column that's needed in our computational table is the x minus 2 squared. So we take each one of those x minus 2 values and square it. So 4 squared is 16, 0 squared is 0, 2 squared is 4, and 0 squared is 0. I know this seems a bit repetitive to some of you, and it is, but it's incredibly important that 1, you're comfortable with the order of operations, and 2, you're able to put all of the information that you need into a computational table on your own. So I wanted you to have lots of examples. So once you have those sums, it's a pretty easy thing to find the values that you've been asked to find. So first, the sum of x's is 14, add up the values. The sum of x's squared is another way of saying 14 squared after you do the substitution. So that equals 196. The sum of the x's squared is 60. Add up the values in that column. The sum of the x minus 2 values is 6. Simply add up the values in that column. And the sum of the x minus 2 squared is 20. Simply add up the values in that column. But if you don't have the order of operations correct, you can imagine how easily one could make mistakes here. If there's anything that you're not comfortable with, put it in the discussion board or send me an email. Now is the time to get all of this stuff straight in your head. So just to make sure that you've gotten all of this that you can get so far, which one of these items, A, B, C, or D, is a correct interpretation of what this equation is asking of you? Good job. It's B. It's asking you, because of the order of operations, square each score, add up the squared scores, and then add 47 to your sum, and you'll have the correct answer. This is something important because you're likely to see this type of question in your quiz. It's not asking you to solve the problem per se, it's asking you how to solve the problem. It's kind of an important difference that you might want to be aware of. It could affect your test-taking strategy. So, true or false, are these the same or no? Of course not. Because of the order of operations, we know that we'd have to do these mathematical operations in a different order, and so, of course, the resulting sum would be different. How about this one? True or false? What do you think? Sure, those things are true. That is, in fact, the definition of the sum of x squared. So those are definitely going to be the same value. And that's all for our discussion of Chapter 1. Good job, guys. Congratulations on making it through. Remember, go back to your to-do list for this week and see what else you need to do. And remember, Quiz 1 is open until 11:59 p.m. this Sunday, at which time it will close. So please make sure that you get all quizzes taken care of before that time. And let me know if you have any questions about any of this. It's my job to help. Take care. Talk to you soon.